Hello learners, welcome back to my channel Shraddha's Physics. Today we will see some problems based on the analytic function. That is, in the previous classes we have already discussed the Cauchy-Riemann equations in the polar form. That is, we have already discussed about to check the function whether it is analytic or not, we are using the Cauchy-Riemann conditions. Now we will use the Cauchy-Riemann equations to solve some problems, and this Cauchy-Riemann equations polar form we are going to use. So our first question is, we have to check whether z power n is analytic or not, where z is the complex number, and here we have considered n is the positive integer. Now here we will consider the plane polar coordinate system, that is, we will consider z equal to r exponential I theta. Okay. So z power n can be written as, we can write this z power n, or this is called f of z. This f of z can be written as z power n, and that is equal to r power n into exponential I n theta. Okay. This is just the power. Now we can write this exponential I n theta by using the Euler's formula. We can split this. So let us first write r power n into this exponential I n theta becomes cosine n theta. This is cosine n theta plus cosine n theta plus iota sin n theta. And this is your bracket close. If I will multiply this r power n inside, this will becomes r power n cosine n theta plus this will be iota r power n into sin n theta. Now we have get separated this real part and imaginary part. So I can write this as, this is equal to u of r comma theta plus iota v of r comma theta. Okay. Now we will use the Cauchy-Riemann equation. The Cauchy-Riemann condition in polar form we can write here as dou u by dou r equal to 1 by r dou v by dou theta, and dou u by dou theta will be equal to minus of r dou v by dou r. So we have to first check what is dou u by dou r. So we have to calculate dou u by dou r will be equal to dou u by dou r. Here you can see that u is equal to r power n into cosine n theta here. This is the value of u, that is the real part. So now differentiating with respect to r, we will get n, the power of r, that is n, into r power n minus 1, and this cosine n theta remain as it is because it is your constant. And similarly taking dou u by dou theta, this will becomes dou u by dou theta equal to, the derivative of cosine n theta is minus n sin theta. So this will be minus n into sin n theta, and this r power n term remain as it is. So I am writing here minus n r power n into sin n theta. Similarly, if we will calculate for dou v by dou r, so this will be equal to, v is here r power n into sin n theta. So this will becomes n into r power n minus 1, and this sin n theta remain as it is. So this will becomes n r power n minus 1 into sin n theta. For dou v by dou theta, this will be equal to, here you can see this is the sin n theta derivative, cosine n theta into n. So this will be n into r power n into, this will be cosine n theta. The derivative of sin theta is positive cos theta and derivative of cos theta is negative sin theta. That is why we will get this. Now if we will compare this Cauchy-Riemann condition, now you will see dou u by dou r is this much, n into r power n minus 1 into cosine n theta. If you will divide in this term 1 by r, so this will becomes n r power n minus 1 into cosine theta. So this first condition satisfy, dou u by dou r equal to 1 by r dou v by dou theta, and similarly dou u by dou theta is minus n power n into r power n into sin n theta, and here dou v by dou r equal to this much. If I will multiply minus r here, if I will multiply minus r, then this will be minus 1 power plus 1, this will becomes r power n only. So minus n r power n into sin n theta. So these two condition also satisfy. So you can say that for z power n the function is analytic because the Cauchy-Riemann condition satisfied. So we can say the function is analytic everywhere. Okay, for every point the function is analytic or it is defined. Now let us check for the function z star power n is analytic or not. Z star means it is the complex conjugate of z. We know z equal to x plus iy. So we can write z star will be equal to z star, that is its conjugate will be equal to x minus iy. This is in the Cartesian representation, and for the polar representation we can write z equal to r exponential I theta, and z star will becomes this z star, we can write this as r exponential minus iota theta. Okay. Now if we will solve for f of z equal to z star power n, z star whole power n. So we can write this as, this is equal to r power n, and this will be exponential minus iota n theta. Okay. We will solve for exponential minus in theta, we will put Euler's formula. So this will becomes equal to r power n into cosine n theta, or we can write cosine minus n theta. Okay, and then plus r power n again sine minus n theta. This is the actual formula of the Euler's. Now we know cosine is the even function, so cosine of minus n theta will be positive cos n theta. So this will be equal to r power n into cosine n theta. Since sine is the odd function, sine of minus n theta equal to minus sine n theta. So we'll write minus, this will be, here one iota is missing, I am writing minus iota, here iota is present, minus iota r power n into sine n theta. Now we have get separated the real part and imaginary part. This is equal to u of r comma theta plus v of, I am writing here iota v of r comma theta. Okay. So here u equal to r power n cos n theta and v equal to r minus r power n sin n theta. So I am solving for dou u by dou r first. So dou u by dou r will be equal to, here you can see with respect to r we are taking the derivative. So this will become, this is u part n into r power n minus 1 into cosine n theta. So this will be cosine n theta. And similarly dou u by dou theta will be equal to, dou u by dou theta will be equal to minus n r power n into sin n theta. This is the simple derivative. And next dou v by dou r will be equal to, here the negative sign is present, so minus, this is our v term, minus n into r power n minus 1 into sin n theta. And for dou v by dou theta, this will be equal to, Here also minus n r power n, this sin n theta will be now cosine n theta. N is here. Now if you will remember the Cauchy-Riemann equation in polar form, we can write it. This is in your polar form. Dou u by dou r equal to 1 by r dou v by dou theta, and dou u by dou theta will be equal to minus r dou v by dou r. Okay. Now see, this dou u by dou r equal to n r power n minus 1 cos n theta, and dou v by dou theta is minus n into r power n cosine n theta. So this condition not satisfied. And similarly for dou u by dou theta, this is minus n r power n sin n theta, and if I will multiply minus r here, so this will becomes minus n into, minus becomes plus n r power n sin n theta. So here is the minus sign. I am writing this expression here. So this minus becomes plus n r power this n minus 1 plus 1. So this will becomes r power n into sin n theta. Okay. This is dou v by dou r while multiplying with minus r. Now this dou u by dou theta, you can see this is the minus of n r power n sin n theta. So this equation also doesn't satisfy. So the Cauchy-Riemann equation not satisfied for z star power n. So we can say that here z star power n, z star whole power n is not analytic. It is not analytic. Okay. Now we will check the reason of the analyticity of function ln z. So let us first write z equal to r exponential iota theta. This is in the polar form. So we can write f of z equal to this is ln z, or we can simply write ln r exponential I theta. Okay. This is in the form of log a into b. So we can separate these two terms, that is log a plus log b, that will be equal to ln r plus iota theta. Okay. You can see here we have separated the real part and the imaginary part. This is u plus iota into b. Here you can see that u equal to, we are writing u as ln of r, this u equal to ln r, and v equal to, here v is nothing but theta. Okay. If you can remember, in the previous classes we have already discussed, that is r equal to mod z, which is equal to the root over of x square plus y square. We have already discussed this. And theta equal to tan inverse y by x. This is the Cartesian to polar representation, or we can say that polar to the Cartesian representation. So we can put this equal to ln of, in place of r we have to write this is the root over of x square plus y square, and for theta we can put this is equal to tan inverse y by x. Okay. Now we will solve for dou u by dou x. So let me write dou u by dou x will be equal to, so for this we have to write this is log x square plus y square root over, that will be equal to 1 by 2 into 1 by, here simply you have to just put this is log a power b, so this is b log a, x square plus y square power 1 by 2, this 1 by 2 comes here, 1 by 2 ln of x square plus y square. So this is the u term. So now this dou u by dou x will be 1 by 2 into 1 by x square plus y square into 2x. So now this 2 get cancelled. this will be equal to x divided by x square plus y square. Okay. Now we will calculate dou u by dou y. So this dou u by dou y will be equal to similarly 1 by 2 into 1 by x square plus y square into 2y, which is equal to 2 to get cancelled, y divided by x square plus y square. So this will becomes x square plus y square. Now we will calculate dou v by dou x. So dou v by dou x equal to v, you know, this is v equal to tan inverse y by x. V equal to tan inverse y by x. So this will be 1 by 1 plus y square by x square into the derivative of y by x again. So that will be equal to, y will be constant. So this will be minus y divided by x square. This is equal to minus y, x square get cancelled, divided by x square plus y square. So this will be x square plus y square. Now dou v by dou y will be equal to, you can see here, this will be again 1 by 1 plus y square by x square into 1 by x. That will be equal to, only x term get cancelled, that will be equal to x divided by x square plus y square. We know the Cauchy-Riemann equation. Cauchy-Riemann equation we know dou u by dou x will be equal to dou v by dou y, and dou u by dou y will be equal to minus dou v by dou x. We have to check these two conditions. Now you can see that dou u by dou x is x divided by x square plus y square, and dou v by dou y is x by x square plus y square. So these two conditions satisfied. Now dou u by dou y is y by x square plus y square, and dou v by dou x is here minus y by x square plus y square. So this second condition also satisfied. So we can say that the Cauchy-Riemann equations are satisfied. But here you can see that the Cauchy-Riemann equation, it will satisfy, but the condition is x square plus y square term. Here you can see that this x square plus y square term, it must not equal to 0. So here I have to write, so the condition is that x square plus y square should not be equal to 0. This is the condition. The Cauchy-Riemann condition satisfied, but x square plus y square should not be equal to 0, and theta should be it defined within the interval minus pi to plus pi. Okay, these are the two conditions. Here we are defining for f of z equal to log z. Okay, or we have written it in the form of u plus iota v. If I take the derivative with respect to x, that will be f prime of z. This will be equal to, I can write this dou u by dou x plus iota dou u by dou x plus iota dou v by dou x. Okay. Now if I will put the value of dou u by dou x, you can see here dou u by dou x is x divided by x square plus y square. So I have to write it here x divided by x square plus y square, and this is iota plus iota. Again I have to substitute for dou v by dou x. Here dou v by dou x is minus y by x square plus y square. So here I am directly writing minus. So this will be minus iota, this will be minus iota y divided by x square plus y square. Okay. If I will solve this, this is equal to, I may write, this is equal to x minus iy divided by, this is x square plus y square. If I will split the term x square plus y square, also we can write it as x minus iy divided by this is x plus iy into x minus iy. So x minus iy with x minus iy get cancelled. The remaining term will be equal to 1 by x plus iy. Okay. This is the f prime of z, or we can say that this is equal to 1 by z. This is nothing but 1 by z. So this equation is, or we can say that this function f of z equal to ln z, this f of z equal to ln z, its first derivative is 1 by z. This is valid, this function is valid as long as z is not equal to 0. The function is valid when z is not equal to 0, and we can say that this ln z is continuous. We can say that this is continuous. Ln z is continuous. This is continuous at every z, but except we can say that this is continuous everywhere except when z is lesser equal to 0. Okay. So this is how we have to check for the function at which condition or at what region the function is analytic, and whether the function is analytic or not, we have to check by using the Cauchy-Riemann condition. If you have not seen the last video about the Cauchy-Riemann condition, then I will share it in the description, so you may check it from there. So this is all for today. Thank you.